Okay, so on page 34, questions numbers 3 to 7. So 3 says to draw the dots and then come up with two different scenarios. So 3A, it's 7 dots equally spaced apart, and then 5 dots equally spaced above the fourth one. And then what are the scenarios? Well, it could be one person walking at constant speed this way, the other person walking at constant speed, they meet at this point, and then maybe one piggybacks the other along here. Or it could be that one's carrying the other at this spot and then drops that person off and they keep going. It's not really throwing something up in the air, because if you're throwing something up in the air, the dots wouldn't be equally spaced here. Okay, so I think it has to be two things traveling along a surface. For the second one, it says draw a square and draw dots closer together in the top left corner, getting further apart. Usually when they do something like this, they're indicating a change in height. So this could be like something rolling down a ramp, could be a kid on a toboggan coming down a hill, could be a bicycle coasting down a hill, right? Getting further apart means they're speeding up. For C, the dots are fairly far apart, they get closer together, and then they spread back out again. Something that's going fast, then it slows down, and then it speeds back up. It could be a car coming to a school zone, so going quickly but then slows down, and then after the school zone speeds back up. Could be you on the Trans-Canada seeing a police car parked on the side of the road, so when you see it you slow down till after you go by, and then you speed back up again. Could be you seeing a yellow light on the road, so you slow down, but then by the time you get there the light turns red, to see a red light maybe, and then you slow down. By the time you get there the light turns green and you speed back up. Don't speed up on a red light. All right, and in D, starting at the bottom, far apart, then getting closer together as they go up, and then leveling out and going equally spaced. That's like something going up a hill. Maybe it's you running up a hill, right? So you're fast at the bottom, but the further you go up, the slower you get, and then finally you hit the level and you just kind of coast at a constant velocity. Could also be on a bicycle. Okay, so that's for number 3. Number 4 says, sketch 2 frames of reference for each of the following. A ferry boat crossing a river. So if it's a ferry boat crossing a river, so here's one side of the river, here's the other side of the river, it probably starts out close together. As it goes across, they'll get further apart, and then as it gets closer to the dock, it better slow down again. That's one frame of reference. The other frame of reference would be you on the boat. It would just be one dot. You don't see the boat moving at all. For B, a subway car moving to a station. So probably going fast on its way in, but as it gets to the station, it's going to slow down. Doesn't say that it stops, but then it'll speed back up after it passes by. And again, the second frame of reference would be you on the car, and it would look stopped. It would just be a single dot. A roller coaster at Canada's Wonderland starts out at the top. As it goes down, the dots get further and further and further apart. It might then like go up in a loop, and so as it goes up in a loop, they'd get closer together. And then as it comes down the loop, they would get further apart again. And that's about where I get sick because I don't like roller coasters. And again, the third one would be just a single dot for you. All right, number 5. Using single points, sketch the following. Distance between the dots. Yeah. Okay, a person on a whitewater rafting trip jumps off a cliff. The immediate thought I have is, why are you jumping off a cliff? Are you in the boat or just jumping off a cliff? If you're jumping off a cliff, well, your dots will be close together to start with, and then getting further and further and further apart until you hit the bottom. Doesn't that sound like fun? All right. B, person hops across the length of a trampoline. So I guess it depends on, are they doing one hop or a bunch of hops? So they will jump with a fairly wide spacing. As they go up, they slow down, and then as they come back down, the dots will spread apart again. and really they should be equally spaced. So you could either do a whole bunch of them to get all the way across, or maybe it's just one big hop. I'm not sure. All right, C, an Olympic diver jumps off a high dive board, hits the water, and comes back up to the surface. So when they jump off a high dive board, they're going to go up with a fair bit of speed until they stop up here. Then they're going to turn around and come back. And again, dots should be equally spaced. And now they're going into the water. They're getting equally spaced, I mean, as on their way up. But they should be getting further apart. So as you go down, they get further apart. When they hit the water's going to slow them down. And then they're going to turn around and come back up to the surface. Okay, so it's going to look something like that. Number 6, explain how the frequency of frames affects the quality of a Disney cartoon. We talked about this the other day, of how quickly you flip through a flip book gives you like more motion. So the more frames, the higher the frequency, the better the image on the cartoon. And then the last one asks you, did roll a marble down a 1 meter ramp. Let me find a spot here. So here's my 1 meter ramp. It goes across the bottom. This ramp is 30 degrees. Goes across the bottom for 2 meters. And then it goes up a ramp that's actually at 40 degrees. That's steeper. So as it comes down this ramp, it's going to get further apart. As it goes across the bottom, we're assuming frictionless, so equally spaced. And then as it goes up this ramp, because this ramp is steeper, it'll slow down quicker and it won't go up as high. Okay, so that's number 7A, and then you didn't have to do B and C because it wanted you to design an experiment and do it. Okay, next video will be the drawing to scale questions.